Welcome to all. This is lecture 10 of part 2. Today, problems for finding equibrant. Something in the class I will tell, very important. Those who want to solve these questions and learn everything, there are two conditions. Condition 1, they should see and thoroughly go through the previous class. That is lecture number 9, where I told given procedure to find equibrant for concurrent, coplanar and parallel force system. And I told one more thing there. For finding equibrant, you have to first find resultant. Therefore, finding equibrant is actually a question for finding resultant. As told earlier, resultant can be either in the form of a force or in the form of a couple. This all I am not talking further now. Therefore, second condition is that you should go through all the earlier classes, how to find resultant, and correctly understand and solve, then only solve. Otherwise, questions will be asked. Someone will tell, see, he wrote something without explaining. Why should I explain when everything is so thoroughly solved earlier? So, these all the questions today for equibrant is 99% homework for you, exercise. See, when I start the question, up to here, I will not explain. Because everything is covered earlier. For the given force system, they want to find equibrant. I will tell some statement here now. I will write some statement. Then, up to here, you have to thoroughly understand. You should solve. This is very simple. Someone will tell, what is this? He just reversed it. Yes, that is my work today. That's all. I told, that's all. Okay. Now, question 1. Before that, before finding equibrant, remember, first always find resultant. Question 1. First consider concurrent force system. That's all, concurrent force system. Question 1. For the given force system, find equibrant. This is a question. First, write here, one note. One note right here. Note. First, forget about equibrant. Where is the color? First, you completely forget about equibrant. Do not bother. Right time, not getting the pen. Okay. No, not getting it. Usual same problem. When I want a particular color, it's here. First, no, that also not there. I have to pause and just 1 minute, I will pause now. Not able to get the color. Okay, got that color. Okay, now make a note. Question is to find equibrant. First, forget about equibrant. Write every time. Find resultant. Now I am not telling. Resultant can be in the form of a force or in the form of a couple. All I am not telling. Class or question mark. Okay. Question mark. How to find? Don't find. Leave it. I will tell don't find. After so many examples given earlier up to today, how to find resultant for concurrent, coplanar and parallel force system, and so much of explanation, and still if you cannot find resultant, not fit to study from me. That's all I can tell. Okay. Happily find resultant. Therefore, remember, throughout today's class, up to here, I will not explain anything. Okay, see. The 4 forces I resolved here. Don't ask me what is going on. Find sigma of x. It is this way will come, left, right. Resultant comes this way. Find r, find alpha. Therefore, resultant for the given force system is as shown here. Okay, this is a resultant. Now, to get equibrant, say Q. See, resultant, I wrote red color R. Now, equibrant, say Q, just to change the color. Class. If it is examination, write a statement. Once I will tell, next time I won't tell. Equibrant for a given force system is equal in magnitude but opposite in direction and will act in the same line of action if the resultant is a force. Whereas equibrant for a given force system is a couple same as if the equivalent for a given force system is same as the resultant couple if the resultant is couple. Same magnitude but opposite direction. Okay, therefore, see, through the point O, this is resultant, same line maintain equivalent. Now remember, by chance you slightly shift it, it will form a couple. So, equilibrium is lost. Okay, this is the answer for this question. Now, I will go for second question. Second question, what I will do is, I won't prepare it, I will write here, see, same problem. Usual problems. I thought of setting the question in front of you only, very simple to set. But that cloth of rubbing I could not get, so I paused. Okay, now, second question I wrote here. Same concurrent, second question. Find equivalent. Okay, same story, resolve, 100 Newton, component will come, 150 Newton, component will come. Remember, two extra forces are there. Previous question also it was there. Right. Now calculate, start. First find sigma fx. Calculate. Zero. Sigma fy. 0. Now some statement, don't see that side. Don't see that side. It is not applicable because I maintained it for next question. See, this is not applicable. I maintain the state because the statement I want for next question. So it's not applicable. Now, one statement you have to write. I will dictate. Sigma fx equal to 0, sigma fy equal to 0. No component in x direction. I have not shown x and y. You know it. Don't tell me, sir, which is x and which is y. Leave the class. Okay. So no component in x direction, no component in y direction. Resultant is sigma fx square plus sigma fy square is 0. Therefore, for the you should write, I am dictating. For the given force system, there is no resultant force. Right. For the given force system, there is no resultant force. Resultant force. Okay, over. Now, but I told you, just because the resultant force vanishes, never come to conclusion in a hurry that system is in equilibrium. That also right here. See, just because you should write everything, just because the resultant force is 0, you should not come to a conclusion suddenly in a hurry that given system is in equilibrium. It is every possibility that the resultant can be in the form of a couple. If the resultant is in the form of a couple, then moment of that couple is constant irrespective of point about which you consider moment. So, as soon as you get resultant force 0, find algebraic sum of moments. This is only when the resultant force becomes 0. To check whether resultant is existing in the form of a couple, find algebraic sum of moments of all the forces about any point. Right here. But, sorry, that's the Kannada word, usual habit. But, right, given force system is a concurrent force system. A concurrent force system cannot produce a couple. Or take moment about this point, 0. Oh, right here. Resultant force is 0. Since it is a concurrent force system, resultant couple, there is absolutely no chance. How? How couple can be formed? When you apply all the force through one point, it cannot rotate. Therefore, undoubtedly, resultant in the form of a couple is not possible. So, resultant force 0, resultant couple is not possible. That means system is already in equilibrium. Right here, I am dictating. The given force system is already in equilibrium. For a given force system which is already in equilibrium, where is equibrant? There is no equibrant. Equibrant is a force or couple to be applied so as to bring to equilibrium. It is already in equilibrium. Therefore, since there is no resultant here, neither in the form of a force nor in the form of a couple, there is no equibrant for this question. write and stop. Now I'll go to coplanar force system. Now next question, very important question for coplanar force system in general. In general. Lastly parallel. Okay. Question 1. Again for coplanar question 1. For the given force system, little space problem is there. Find the equibrant. Copy the question. Okay, now, first note, forget about equibrant. Next time I won't tell it. Find resultant. How? Don't ask me how to find. Last time I told. If you do not know how to find, right now, close and go to some entertainment video in the YouTube. Don't study structural engineering. Class, correctly find resultant systematically. Okay, start. Resolution I had done it. See, and very important, we will solve in newtons and millimeter. See, all Newton. But the two couples are given in Newton meter. That you have to convert to Newton millimeter. I already told it. Okay, now. See, also, they told where is the couple point here. This is not required. See, when you take moment about any point, couple into is not there. So, you can make a note. This distance is waste. This is useless. This is also useless. This is also useless. Okay, now, start. Enjoy. First, sigma fx. I am not taking upward routes for sign convention. You find with sign convention. Systematically find sigma fx over sigma fy over. No sign here. Therefore, sigma fx this way, sigma fy this way, resultant this way, alpha x this way. Find r and alpha x. Now, this is a coplanar force system. See, earlier question, concurrent force system. Resultant passes through that common point. You know the line of action. But here, this is a coplanar force system. See, resultant is like this. It can be anywhere. Therefore, again waste of time. I told at least 1 hour I talked. You have to find magnitude over, direction over. And also you have to locate line of action. So, I want to waste time. In the class earlier I wrote systematically. Now you have to locate line of action. Let x be any point in the resultant. Consider the point x wherever you want. If the force is inclined, if the force is purely vertical, consider x on horizontal line. If the force is purely horizontal, it will cut only vertical line. Everything told earlier. So this point is x. Now next locate x. Okay, let us locate x on AB line, cutting somewhere here at x to right of A. AB. Okay. Happily get the value of x. Sorry, I cannot tell how to get x now. I don't know. First of all, I don't know. I am very weak in engineering mechanics. Okay. Get the value of x. I have done calculation very carefully. Answer is correct. See, especially when a homework or exercise given, I double check it. Because why? If mistake means, suppose you make a mistake, you will not be knowing it. So x will come minus 578.69. Therefore, for the given force system, resultant is as shown here. See, resultant R 218.74 with x direction 52.26 degrees, and it will cut the AB line. We considered point x to right of A by x. X came negative. From A, come left side by 578. This is 850, 875. So, somewhat scale. This is the resultant for given force system. Okay, first of all, I should have given the question and directly this answer. I should have written the question here. Here only put the answer without one simple hint also. But why I give? Suppose you make one mistake in resolution. At least you should know it. Now to get the equibrant, say Q, class. I told already. To find the equibrant, what you have to do? It is, see, you write here. The resultant is a force. It has magnitude. You should write. It has magnitude, direction, and line of action. The equibrant is once again a single force to be applied to reduce the system to equilibrium. So that equibrant force should have exactly same magnitude as resultant, should have same line of action. That is, it should cut at what distance? Same distance, but opposite direction. By chance you put somewhere else, it will create a couple. After all the statement, answer is C. Okay, I put equibrant with a color here. This is equibrant, okay, space C. This way is there. Equibrant is, I told Q. Q equal to same answer. Instead of R, I wrote equibrant as Q. How much? 218.74 Newton, which will cut here at what distance? 578.69 millimeter, and angle with the x direction is 52.26 degrees. This is the point A, this is the point B, this is the equibrant for the given force system. Okay, now next question. Start next question. Question 2 for coplanar force system in general. For the given force system, find equibrant. Question given. Okay. Don't see this number. This is my personal number. You will know it later. Someone will ask, sir, what is that one? Not for you. Now, first, same statement. First, you find resultant. Okay, start. Sigma fx. Calculate. 60, 90, 30. Oh, 0 will come. Sigma fy, 50, 70. Oh, sigma fy also 0. Therefore, one statement you have to write. B, I am dictating. Component is algebraic sum of component in both x and y directions are 0. Resultant, if resultant is a force resultant, its magnitude is root of sigma fx square plus sigma fy square. Since both sigma fx, sigma, actually they are equilibrium condition, are 0, for the given force system, there is no resultant in the form of force. See, statement. For the given force system, again I am telling, be careful. For the given force system, there is no resultant in the form of a force, because your R equal to 0, magnitude. Okay. Now, one statement you have to write. Just because resultant force 0, blindly don't tell it is in equilibrium and no equibrant. Wrong. It is possible that when the resultant force is 0, there is every chance that resultant can be in the form of a couple. Therefore, now let us check whether resultant exists in the form of a couple. If it exists, all you are right. Moment, the magnitude of the moment of that resultant in the form of couple is equal to algebraic sum of moment of the entire force system about any point. You take any point, sigma m about whichever point you want. Whichever point you want. I will take clockwise positive. Equal to, it will come minus 23300 Newton millimeter. Oh, therefore, resultant couple is there. Therefore, right here, for the given force system, resultant is existing. Resultant is there, not in the form of a force, but in the form of a couple. Clockwise you took, negative came, means anti-clockwise couple of 23300 Newton millimeter. Therefore, resultant for given force system is as shown below. See, resultant are in the form of couple. Okay, couple. It is not a magnitude, equal to anti-clockwise of, you can write here only, 23300 Newton millimeter. Okay. Now write here. Now to get equibrant statement. If the resultant is in the form of a force, I told statement. But now you have to write statement. In this question, resultant is in the form of a couple, and we got in the form of a couple. Therefore, equibrant is also a couple of same magnitude, but in opposite direction. Therefore, the equibrant for the given force system, say Q, okay, Q will do, say Q, if you write Q, the color is not working, same problem, that green color is not there, like paste it somewhere, here, okay, the resultant equibrant Q is this anti-clockwise, clockwise couple of 23300 Newton millimeter. Okay, over. This question over. Now do one thing, I won't prepare a question, I'll first set the question in front of you only. Question 3. I want to finish now on coplanar. For the given force system, find equibrant. Question once again, question number 3. Simple question I will give. Why waste time? Okay. I want to save the time. No point in wasting time here. 60 Newton. 60 Newton. This height is 400 millimeter. New question. And then, simple question. Down of this distance is 400 or 240. 240 ಅಂದರೆ ಒಂದು 80 Newton and upward force of 80 Newton. 8 how much I told here? Distance 400 millimeter, not 300. Out of scale, this is 300 millimeter. I'll check the answer once again. Yes, correct, 300 millimeter. Out of scale. Okay. This is a question. Enough. I can give more, I can set the question with more number of forces. Concept, in the notes I will give more questions. Okay, start. First, same statement. First defined for resultant force. Sigma fx plus 60 minus 60, 0. Sigma fy minus 80 plus 80, 0. No resultant in the form of force. Still I told, if there is no same statement I told for last question, you are right. But if resultant is force is 0, there is every possibility that there is a resultant couple. So therefore check the resultant couple to consider sigma m about any point of your choice. But you should not worry, take a point, calculate. You take clockwise positive. It will come 0. Oh, right. Oh, that's all. Don't see that side. That is not. This is not applicable because there is no resultant here. This is for next question. Therefore, right here, resultant force 0, resultant couple 0. Therefore, there is no resultant for the given force system. When there is no resultant, where is equibrant? It is already in equilibrium. Or sigma fx 0, sigma fy 0, sigma m 0 are basic conditions of static equilibrium. All three are satisfied. Therefore, the previous question, sigma m is not 0. How much you got? Some minus 233 you got. That's why I told resultant is there. Now, no resultant, over. Now, go for last part of this class. Go for same thing for parallel force system. Parallel force. Sufficient, parallel. First question 1. Question 1, question 2, question 3. What I will do is in a corner, I will prepare the question to save the time. Single stretch I will do it. Somewhere in the corner, I will prepare the question because I should set the question. One question I want resultant force. One question I want resultant for couple. One question I want no resultant. Now, concluding part. Lastly, for parallel force system, I decided to not to waste the time. Direct question answer. These are all questions set by me. I will remove it. Okay. See, for right here, question is, I have not written the question here. Write the question first. Question. For all the three given force systems, find equibrant is the question. Right there. Find equibrant. I should not use red color. Okay. For all three questions, find equibrant. First question is here. Parallel force system. Happily find the resultant. Magnitude will come 50 Newton down. Line of action will come from A at 3.8 meter. I will cross check it now. I will just check from that side, just for safety. Minus 70 into 2 plus 50 into 5 40 into 8 divided by 50. I'm getting 4.2. Yes, correct. Totally 8 meter. 4.2 correct. Okay. This is the resultant. Equibrant. Down 500, up 500 at same distance. Over. Correctly solve. Question 2. Solve. Resultant. First, calculate resultant force. Down 100, down 50 is down 150. Up 120, up 30 is up 150. Oh, resultant force vanishes. But couple can come. So take moment about any point. I got and minus 430 means resultant is anti-clockwise couple of 430 Newton meter. Equibrant is clockwise couple of 430 Newton meter. Oh, sorry, not millimeter, meter. Okay. Okay, then come to last question. Here, find resultant. 165 down, 200 down. That is 365 down, 365 up. Resultant force vanishes. But resultant couple can come. Take moment about any point, but moment when you take, it will become 0. So this question, resultant force also will come 0, resultant couple also will come 0. So right here for question 3, no sketch actually, there is no resultant neither in the form of a force nor in the form of a couple, or you can tell this given force system is actually in equilibrium. Therefore, no equibrant also. I will tell you how I set this question. See, very simple. How I set the question, I will tell you. I'll remove this one now. I considered a simply supported beam. See, one support here, one support here. I applied a load of 200 Newton. I applied load of 200 Newton and I applied one more load upward of 30 Newton. This span I had taken 4 meter. This I took 3 meter overhang. This I took 2 meter. I found support reactions. Remember, support reactions you have to find based on basic conditions of static equilibrium because the member is in equilibrium. So when I took moment about A point, I got 200 into 7. This all will come later. Minus 30 into 2 divided by 4. I got reaction of up 335. That force only I have given here. Then for equilibrium, sigma b is 0. I got down 165. That only I gave. Or question number 3, I imagined a beam, applied some loads, found the reaction because in case of beam later you will be knowing action and reaction together will be in equilibrium. So first question, resultant is force, equibrant also is force. Second question, resultant is couple, equibrant also couple. Last question, neither resultant nor equibrant. Now solve all the questions. Get ready. This is class number 10, lecture number 11. Thank you.